Hi, Mrs. Stanley here. Let's review monomials and the exponent rules that we use to simplify them. So first of all, a monomial is a constant, a variable, or product of numbers and variables. Notice that word or. It doesn't mean that it has to be all of these things. It could be any one. So here's some examples. A constant, we could just have the number 6. That is a monomial. We could also just have a variable. For example, we could just have y, or x, or m, or whatever other letter you want to use. That would be just a variable, or a product of numbers and variables. So that means we could have 6y together. We can also have exponents involved. For example, it could be 1/2 x squared y. That's an example of a monomial. The key thing to remember visually is that you won't see any adding or subtracting. And that is true from a mathematical perspective also, but just when you're glancing at something, if you see any adding or subtracting, then it's definitely not a monomial. A monomial is only one term that has a constant, a variable, or a product of numbers. And the next thing that we can notice is that we're going to use the exponent rules to simplify monomial expressions. So let me go ahead and change my marker color. The product rule. This is when we have two terms, two monomials that are being multiplied together. The key thing is that they have to be the same base. In this example that I'm drawing here, we have x to the power of a times x to the power of b. The base is x. That has to be the same, and when it is, we can just add the exponents. So in a real example with numbers, we might have x squared times x cubed, and when we put that together, we would say 2 plus 3, which would be 5. So that's an example of the product rule. The power rule is when we have a term with an exponent raised to another exponent. So, for example, if I have x to the power of a raised to the power of b, this time I'm going to multiply my exponents. So it becomes x to the power of ab. Looking again at an actual example with numbers, let's say that I have y to the 6th power cubed. Then in that case, we would do 6 times 3 and get 18. Okay, then we have the quotient rule. This is when we have two terms that are divided. So I could have x to the a divided by x to the b. In this case, we're going to subtract. And it does matter. You have to do the top exponent subtract the bottom one from the top. So it's top minus bottom. So x to the a minus b. If these were actually numbers or letters, real examples, we might have b to the 5th over b squared, and in that case the answer would be b to the power of 5 minus 2, which is 3. The negative exponent rule, whenever we have a negative exponent, you may recall, it basically is letting us know that that term actually needs to be in the denominator. So we would flip it over to take the reciprocal, 1 over x to the a. If it's already in the denominator, then we would take the reciprocal and it would move to the top of the fraction. So it is telling us to take the reciprocal, not just that a negative has to be in the bottom. Notice when it went to the bottom, it became a positive. So if I had the example, of m to the negative 2, that would be the same as 1 over m squared. And then for the zero exponent rule, hopefully you remember anything raised to the power of 0 is equal to 1, except for 0. 0 is an exception because 0 to the power of 0 is undefined. So let's first write our example. X to the 0 equals 1. I'm going to make a note here that 0 to the 0 is undefined because that's the one exception, and you do need to keep that in mind. You don't want to fall in a trap where you make a mistake because of the 0. So let's say this whole thing is raised to the power of 0. As soon as you see that 0 exponent, anything raised to the power of 0 is 1. Because the purpose of this video is just to remind you of the rules, I'm not going to work out any of these examples. I think that you can do that on your own.